So we are talking about linear inequalities now. That's one of the last things that we have to do before our test. So linear inequalities. Linear inequalities are going to be extremely similar to linear equations. The only difference is going to be the inequality sign. So similar to linear equations, but with an inequality sign. Finding the solution is going to be all of the ordered pairs that make the inequality true. That make both inequalities true. We could also say it's where the shaded regions match or overlap. So just talking about graphing and things like that, or solving, we're going to solve these the same way. So we'll just do two of them. Notice this is my X and this is my Y. All we're going to do is plug back in. So we would have 2 times 2 minus 3 times 5. Is that smaller than 15? 2 times 2 is 4. 3 times 5 is 15. Oops. 4 minus 15 gives me negative 11. And negative 11 is smaller than 15. So let's go ahead and do the counterexample. We'll do the next one. 2 times negative 1 minus 3 times negative 7. Is that also smaller than 15? 2 times negative 1 is going to give me negative 2, or 3 times negative 7 would give me negative 21. And a negative makes a positive, so we would have negative 2 plus 21, which means we have 19 is smaller than 15. No, not true. So let's talk about graphing. When it comes to graphing, we need to put it in slope-intercept form. Which is y equals mx plus b. And then we're going to use either a solid line or a dotted line. Solid lines are whenever we have that equals bar underneath. And dotted is if we do not. So the way I think about it is this tells me to draw a straight line. If it's not there, then I don't draw a solid straight line. I would draw a dotted line. The last ones we have is shading above and below. If we have greater than symbols, we shade above, and if we have less than, we shade below. So let's go ahead and do an example. Notice this is not in slope-intercept form, so we do need to put it that way. First thing we're going to do is subtract that 2x away. So we would now have negative 3y is greater than 15 minus 2x. Now we need to divide by negative 3. Now up here, I didn't mention it, but we've talked about it before. Make sure that you flip your inequality symbol if you're multiplying or dividing by a negative number. So notice we're moving this negative 3. Since we are moving in negatives with multiplication and division, that means our sign is going to flip around. 15 divided by negative 3 is going to give me negative 5, and negative 2 divided by negative 3 will just stay 2/3. And I need to reverse the order I wrote that in. So I want to just take my terms and flip them around. So I'd have y is greater than 2/3 x minus 5. And graphing, we need to go up, down to 5. 1, 2, 3, 4, 5, and put a dot. And then this says go up 2 over 3. Up 2 over 1, 2, 3. Up 2 over 1, 2. I can't go over 3, but it would be somewhere right there. Now, notice this is not equal to, which means we have to attempt to draw a dotted line. So it would look something like that. And since this says greater than, we will shade above, meaning all of these numbers up here would work for answers. Let's go ahead and do 2 more examples. We're going to do these first 2 right here. These are already solved in slope-intercept form, so we're just going to start by going down 5. 1, 2, 3, 4, 5. We get a dot. And this says go up 1 and right 3. When in doubt, we're always going to try and go right instead of left. So if this would have been negative, like it is over here, we would go down 2 and still go right 1. So we're going to go up 1 and over 1, 2, 3. 1, 1, 2, 3. Up 1 over 1, 2, 3. And I can't go any farther. Now we look, there is nothing below my inequality, which means this is going to be a dotted line. So down 1 over 1, 2, 3. I want to finish out the 1, 2, 3. I want to finish my line out. There we go. And we're going to make this into dots. So we could look at this and say, well, y is greater than, which means I'm going to shade up here. If that doesn't really work for you, if that doesn't make sense, the other thing we could do is pick a random location. So in this case, I'm going to choose 0, 0. We want to choose a number that is not on our line. So we could also choose this number, or we could choose this number, but 0, 0 is going to be the easiest for the most part, and plug it in. We would have 0 is greater than 1/3 times 0 minus 5. Is 0 greater than -5? Yes. And that means we want to shade that region in. So we come over to the next one. We start at -1. And this says go down 2, right 1. So down 1, 2, right 1. 1, 2, 1. 1, 2, 1. And this one does have that equal sign underneath, which means we will draw a solid line. Should look something like that. And again, I could look at this and say, well, y is smaller than, so I'm going to shade down here below, or we can go with picking a number. Let's pick 1, 1 this time, just to change it up. So I'm going to say 1 is less than or equal to -2 times 1 minus 1. 1 is less than or equal to -2 minus 1. That says 1 is less than or equal to -3. That is not true, meaning we do not want to shade in that number. So we shade away from the number, which is what we did. Now we're going to move on to systems. A system of inequality is going to be the same thing that we did for systems of equations. It's going to be 2 or more linear inequalities that are graphed together. And to find the solution is going to be the overlapping region of points that satisfy both equations. inequalities, N-E-Q-U-L-I-T, inequalities. We could also say where the shading area meets. So let's go ahead and graph some. The first one I'm going to do in red. And the second one I will do in purple. So let's start with our red one. This says to go down 1, and then again go down 1 over 1, down 1 over 1, down 1 over 1. And notice there is no equal bar. So this is going to be a dotted line. And now when I look at that, I see y is bigger than, so I'm going to shade up top. Let's start with the purple one. This says to go down to 5. 1, 2, 3, 4, 5. And it says go up 1 over 1, up 1 over 1, up 1 over 1. And again, it is not a solid line. So we are going to do another dotted line. This one says that y is smaller than, so we're going to shade below. And where do our two shaded regions match? They match here, where our red and our blue, red and purple combined. And a solution to that is just going to be any one of these random points that we see. So right here could be a solution, or here could be a solution, or here could be a solution. They're all solutions. So let's go ahead and do one more. We're starting at +7, so up 1, 2, 3, 4, 5, 6, 7. Did I count wrong? 1, 2, 3, 4, 5, 6. No, I did not. That is 7. And up 1, 2, 3, 4 for the second one. Let's do the first one in blue. And we'll do the second one in red again. And I already found my starting point, so let's go back to my blue one. I'm going to go up 1 and right 3. Up 1 and 1, 2, 3. Now, this is again going to be a dotted line because there is no equal bar underneath our inequality. And I definitely don't have enough room or enough dots to make myself a dotted line. So I need to go down 1 and left 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2. It should be somewhere right there. And then we will dot it out. For our red line, our second inequality, we started at +4, and this just says go down 1 over 1. 1, 1, 1, 1, 1, 1. And this is going to be a solid line. So I can get out the easier one. I definitely screwed up my line. Let's try it again. Let's make a new line. Our line should look something like that. And then let's do the guess and check method. So let's guess each of them at 0, 0. So we would have 0 is less than 1/3 times 0 plus 7, which means 0 is smaller than 7, which is true. So our blue line will come down. Our red one is going to be 0 is greater than or equal to -0 plus 4, meaning 0 is greater than or equal to 4, which is not true. So we're going to shade away from 0. And where we meet, be this little region up here, is our solution area. Last thing I want to do is talk to you about word problems. Word problems are going to make this seem a lot more, should help you understand this a lot more. So let's talk. First, suppose you're buying flour and cornmeal in bulk to make tortillas. Flour is $1.50 per pound and cornmeal is $2.50 a pound. We want to spend less than $25, but also have at least 6 pounds. So one of these is going to have to do with the $25, and the other one is going to have to do with the 6 pounds. We'll have a plus sign in the middle, and it'll be, let's say we're going to put flour down here, corn on the side. So we could say our corn plus our flour, the weight of corn plus the weight of flour needs to equal at least, meaning it should be bigger than, but it can equal 6 pounds. So we can say this is X plus Y, or our flour plus our corn. So when we come up top, it's still going to be X and Y, but we need to put a number with it. And in this case, what number went with flour? 150. What number goes with corn? 250. And we need no more than. We want to spend less. So we would have 25 being the biggest, and it can also equal 25. Now we need to solve each of these. Let's start with the bottom one. It's going to be simpler. We want to solve for y, meaning subtract x on both sides. And we would get y is greater than or equal to negative x plus 6. I'm going to solve this one over here. So I have 1.5x plus 2.5y is less than or equal to 25. We're going to move our x to the other side. So we would have 2.5y is less than or equal to negative 1.5x plus 25. And then we divide each side by 2.5. Negative 1.5 divided by 2.5 is going to give us 0.6, or we like fractions more, 3/5. Negative 3/5 x. And what is 25 divided by 2.5? I believe it's 10. It is 10. Now we have our equations. We can graph them to find solutions. So we need to go up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up here is 15. So we're going to start at 10, and this says to go down 3 and over 5. So we'll count down 1, 2, 3, and right 1, 2, 3, 4, 5. Down 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, and 5. And this is going to be a solid line because it does say it can equal. So our line should look something like that. And now we're going to graph our red one. And this says to start at 6, and again, go down 1 over 1 every time. And that is also a solid line because it says it equals. Our line would look something similar to this. Now, we can assume without even testing that this inside area will be where we meet. Because for the blue line, it's a smaller line. So the blue line went down and the red line goes up. So that is in fact where that's going to meet. So now we need to find two solutions. Anything inside of the shaded region will be a solution. So anything here we can use as a solution. So we could use this point here because it's inside of our shaded area, which means we're going to buy 1, 2, 3, 4, 5, 6, 7, 8 flour tortillas and 0 corn. We could also pick this number here, which means we're going to buy 3 flour and 6 corn. We could pick any of the numbers inside of the shaded region. And that is how we would solve our word problems. We'll do one more. Seafood restaurant owner sells salmon and perch. We're going to put perch down here at the bottom, salmon on the top. So we sell perch and salmon. Perch is $4 a pound, salmon is $3. We want to buy 50 pounds, but cannot spend more than $240. So we said perch is X, X plus Y. So we'll call this one perch plus salmon. How many pounds do we want? At least 50. So more than or equal to 50. For the second one, again, we're going to have X plus Y, and then the other number will be how much we're paying, $240. But how much does each of them cost? Our perch is $4, our salmon is $3, and no more than, meaning $250 needs to be the biggest. Let's go ahead and solve the top one. That'll be easy. We just subtract X on each side, and we end up with Y is greater than or equal to negative X plus 50. On the bottom, again, we're going to subtract our X on both sides. And we end up with 3Y is less than or equal to negative 4X plus 240. Now we need to divide each of them by 3. 240 divided by 3 is going to give us 80. So for our second equation, we would have Y is less than or equal to negative 4/3 X plus 180. Nope, not 180, just 80. So I'm going to say we should probably count by 5s. Can we count by 5s? There's 15 lines. We can not count by 5s. Let's count by 10s then. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 150. And I erased it. Let's write it over here. This is salmon. On the bottom, we'll also probably need to count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and that one will be 150. For perch and salmon, for the top one, the one in red, it needs to start at 50, and that says go down 1 over 1. Now we counted by 10s, so what I want to do is multiply these each of my little fractions by 10. So instead of 1 over 1, it would be 10 over 10. Now I can go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And again, it will be a straight line. So it'll look like that. For the one in purple, again, I want to multiply each of these by 10, so it would become 40 over 30. So now I don't have to worry about going down 4 out of 10. I just go down 40 and over 30. So we're going to start at 100, 90, 80. And this says go down 40 and right 30. So 10, 20, 30, 40, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. So we have a really small gap on this one. And again, it can be assumed that they're going to meet in the middle because that's kind of the entire point of the exercise. Or we could say, well, red says to graph up and purple says to graph down. So they're going to meet in the middle. Let's pick our two numbers. So we'll have blank perch and blank salmon. Blank perch, blank salmon. Let's pick some numbers. I'll choose this one because it's where they cross and they're both inside, and I'll choose this one. It's where they cross and they're both inside. So down here was perch, right? Yep. And that's saying we bought 10 perch and 50 salmon. 10 perch, 50 salmon. And now we're saying we bought 40 perch and 20 salmon. So we could also put 40 perch, 20 salmon. And both of those numbers will satisfy our restrictions.